So here is a nice question in group theory. The question is, let's say H is a open subgroup of R plus, show that H equal to R. That is, the only subgroup of R which is open is the R itself. So let's say the question. So given H is open in R, that means H is contained in R. So now if we are able to show that R is contained in H, then we are done. If H is contained in R and R is contained in H, that means that H equal to R. Then we are done. So since H is a subgroup, that means the identity element which is 0 is contained in H. Now also H is open. That means that there exists some epsilon greater than 0 such that minus epsilon comma epsilon, this open interval is contained in H. That is coming from the definition of open set. That is, if X is a point in H, then there exists a neighborhood which is also contained in H. Now we will apply Archimedean property on the mod R belong to R and epsilon greater than 0. Now by Archimedean property we can say that there is some n greater than n which is natural number such that n epsilon is greater than mod R. This is just from the Archimedean property. If one positive R and positive epsilon is given, then I'll get some n such that n epsilon is greater than R, mod R. From where I got that mod R by n is less than epsilon. This is just some manipulation, which implies that minus epsilon is less than R by n is less than epsilon. That means that R by n is contained in minus epsilon to epsilon. Here. Now recall that minus epsilon to epsilon was contained in H. That means that R by n is contained in H. Now since H is additive subgroup, that means if I add R by n times, then that element will also contain in H. That means n times R by n is contained in H. Since H is additive subgroup, that means R is contained in H. Now recall that R I took from R, the capital R. That means that R is contained in H. And so we are done. So this is the proof of the question that if H is open subgroup of R, then R equal to H. Here I have a exercise problem for you. Find all injective homomorphism from Z cross Z to Q. This is an exercise problem. Thank you.